Okay, I wanted to get something up on exponential and logarithmic functions, and with the primary goal of pre-calc in mind. And one way of looking at pre-calc, it's all about understanding the connection between equations and graphs really well. And so you could say the main point is graphing equations without doing any actual work, right? If you have the equation of a function, you could always make a table and plug some numbers into it and get a sketch of the graph that way by doing some actual calculations. But that's like the hard way to go. That takes actual calculations and doesn't make use of the nice patterns and stuff that we know about these things. The key points to exponential graphs, and these are versions of exponential functions, the key points to it come from a couple of the basic rules of exponents. One is that whatever your base is, if you put a 0 on it, you get 1. Anything to the 0 power is 1, as long as b is non-zero. And the other thing is that whatever your base is, if you put the exponent 1 on it, you just get back what the base is, right? The first power doesn't do anything, it's the identity. So those are the key points to this kind of thing. When your input is 0, you get 1, and when your input is 1, you get the base again. That's enough. Once you get a sense of what these exponential graphs look like, that's enough to draw the graph for the functions. Just 2 points. And so if that's all you knew, that wouldn't be great. But we know what these things look like and what the behavior is. I'm assuming you've gotten into this thing some. But those are the 2 key points to it, and you know it's going to have that horizontal asymptote in one direction and keep going like that. That's kind of what it looks like. So those are the key points to the thing, and that concept and those 2 key points, along with the transformations that we already know about, enables us to do all kinds of exponential graphs really quickly here. If your base is less than 1, well, that same 2 points is going to tell us kind of what's going on here. If you put in 0, you get 1, and if you put in 1, you get the base. But if that's below the original point, I'm still looking at the point 0, 1, and now the base is below that, so my second point is below this. Then it must be the other kind of exponential curve that goes this way, right? My asymptote must be on that side. And there we go. That's what the graph for that one looks like. So those 2 key points give you a y-intercept and kind of a direction in which this thing is going. And we'll just do transformations of that then. If I have transformations to it, I might build a little bit bigger table. I'm still thinking, what if my exponent is 0 and what if my exponent is 1? I get 1 and the base for 2 to the x. And then 3 times 2 to the x is just going to stretch it vertically, so my y values will be tripled on that. It'll go through 0, 3, and 1, 6. So this got stretched out. My exponential graph got stretched out so that it goes through 1, 6, 0, 3, and 1, 6. So it's just had a vertical stretch done to it, but it's the same kind of shape. Instead of going through 0, 1, it goes through 0, 3. So that affects the y-intercept and stretches the entire graph vertically. This one's a vertical shift up 4 places from where it would normally be. So my same 2 points, e to the x would be going through 1 and then e. Now e is between 2 and 3. I can eyeball that on the graph. It's almost 3. But the plus 4 is just going to shift those up. So I'm going through 0, 5, and whatever e plus 4 is, that's going to be close to 7 on the graph. So I'm shifted up. That actually affects where my asymptote is. It's going through this point, and when you get out to 1, it's quite a bit higher. It's big exponential, but the vertical shift actually moves everything up, including the asymptote. So I know to extend that out this way, but it's not leveling off to 0 now, it's leveling it off to 4. Your asymptote is in the one directional horizontal asymptote is affected by a shift. It's not affected by a stretch, because stretches and compressions just affect how far things are from the x-axis. So if the x-axis was your asymptote, stretching it or compressing it, the x-axis is still the asymptote. It's just stretched a little further away from it, but still approaching the same thing. But shifts, of course, move everything, so that asymptote gets shifted then. Vertical shifts. You could do horizontal shifts with this stuff also. This one, there's a little bit more going on, but you got to get used to how to rewrite things algebraically so that you have a nice algebraic expression. You could think of this as a horizontal compression, but there's an easier way to think about it, right? Multiplying exponents, 2 times x, that should be the same thing. 3 to the 2x is the same thing as 3 to the 2 to the x, or 3 to the x to the 2. That's the situation in which you multiply exponents. And this is actually the easier way to think about it here. I can rewrite that as 9 to the x minus 6, and then it's just an exponential with base 9 shifted down 6. So my simple points are 1, base 9, that's the 9 to the x part, and then if you subtract 6 from it, you get -5 and 3, and your asymptote is shifted down 6 also. So you got a one-sided asymptote down here, 0, -5, and 1, it's already up to +3. So it's that really steep exponential thing, right? 9 is a big base, so the shape of the exponential is exaggerated. It accelerates up like crazy. Exponentials do, but the bigger the base is, the crazier that rate of increase is, and the faster it drops off toward the asymptote there. So that's going to be very close to -6 pretty fast. Now, logarithms are turned around the other way. They're defined and thought of as the inverses of these exponential functions. Inverse always switches x and y. So my 2 key points for the exponentials, based on these ideas, my 2 key points for the exponentials were 0, 1, and 1b. 0, 1, and 1b for exponentials. The key points for logarithms are going to be 1, 0, and b1. The log of 1 is always 0, and the log of the base is always 1. So for something like this, my 2 key points would be 1, 0, 4, 1. For a basic logarithm, your key points are either this and x-intercept now, and when x is 4, I get 1. And your asymptote that was following the negative x-axis, when you switch x and y here, it's now following the negative y-axis. And logarithms have that basic shape with a one-sided vertical asymptote here, and a domain from 0 to infinity, right? That's logarithms. And those can be shifted around and have stuff done to them also, but using those key points. So for log base 2, key points would be 1, 0, and base 1. That's x log base 2 of x. This is a vertical stretch of that one. So multiplying the y values by 3, I'd get 3. I'd get 0. 0 times 3 is 3, and 1 times 3 is 3. So I'm going through 1, 0, and 2, 3. 1, 0 still. And by the time I get out to 2, I'm up here at 3. It's just the same kind of shape, only stretched a little bit vertically. The asymptote's in the same place, and this is kind of stretched out, but still kind of getting flatter and flatter as you go out there. That's the shape of a logarithm. These 2 key points are enough to get a sense of how they work. This one's got a vertical shift on it. If you take that kind of shape and shift it up, you're moving the points. The asymptote stays the same because you're just sliding upward on this thing. And your y values are going up 4. So this is just log of x. I didn't put a base down here. So if you have log written without a base, that's understood to be log base 10. So my 2 key points for common log or log base 10 are 1, 0, and 10, 1. That's my base. And so if I do the plus 4 on it, I'm going to get 4 and 5. So when x is 1, I get 4. And when x is 10, I get 5. All the way out to 10 before this thing hits 5. That doesn't seem like much to go by, but knowing my domain is still just positive x, my asymptote still has to be at 0. I know what the rest of this thing looks like. It's just really exaggeratedly flat because a big base makes this logarithm shape exaggerated. It stays really close to its asymptote, and it grows really slowly because it's a log base 10. So that's a quick way to get to basic graphs there, and you get reinforcement of how these transformations of the graph work in a new setting here.